Networking, network devices. We've discussed now the network types and the network topologies, right? The types being LAN, WAN, MAN, PAN, etc., all these area networks. But these are logical distinctions for the most part. They tell us what kind of network it is, but they really don't tell us how that network communicates. And same with the topology. Well, it's great to know physically how everything's connected, but what good is that without knowing what is physically connecting them to each other and allowing the network to work? So what we're going to talk about in this video is this one right over here, the network devices. What allows all these computers to communicate with one another from a device level, and the different devices we're going to find on the network. After we talk about this video, then we will get into the media that connects all these devices, okay? But first we need to talk about some of these devices, and there are a bunch on the exam. We're going to just briefly go over some of them in a very brief way. If you're going to continue on to Network Plus, that's where we'll cover them in much more depth. And in Network Plus as well, it's going to be helpful to remember the stuff we talk about right now because it will feed over. So some of the devices we're going to talk about include a hub, which is an older device we don't see a lot anymore for reasons we'll describe. A switch, which if you recall when we were talking about LANs, allows all those local area network computers to communicate and connect with one another. A router, which if you recall we talked about, allows the LAN to get out to the WAN. And I want to make a distinction here with the router in just a second. We're also going to talk about a wireless access point, which allows for what are called unbounded connections, meaning that there is no wire. They are wireless. We're also going to look at a Soho wireless access point and router. This is a special device that we see a lot in the market nowadays, especially in small offices and homes, places that they don't have their own IT department. And Soho stands for small office, home office. So it's important when you see Soho wireless access point / router, or they might say it's a Soho access point or a Soho router, whatever it is. When you see Soho involved there, just remember that we're dealing with a device that does many different things. The router we're talking about here is only a router. A Soho router, which is the thing a lot of people call a quote-unquote router at their house, is different in an extent because it does more. And we're going to talk about those in great detail later. A bridge, which in some ways is linked to a switch. We'll talk about that. A more advanced device that you probably won't deal with as much. Network attached storage, which is sort of like a hard drive for the network. And we'll talk about that. And the reason these are now devices is they're their own miniature sort of computers that don't have an operating system. They only serve storage to the network and to the network at large, which we'll talk about. A modem, which is an older device used mostly for dial-up connections. And I'm going to point it out now, although we'll see it later. These two acronyms you want to know, POTS and PSTN, plain old telephone system, and public switched telephone network. Modems allow communication over those, and you will see these a lot. Sometimes they'll say, what device allows communication over a POTS network, and that'll be a modem. But again, we'll discuss that in more depth in just a little bit. Then we'll also look at internet appliances. There's a lot of different definitions for this, but it's really any device that gets you out onto the internet. One might consider their smartphone an internet device or an internet appliance. And then a firewall, which is mostly used for security, and we'll talk about it more. A Soho router has a firewall built in usually, and this is for security, allowing certain things in but not everything, like a wall of fire that allows certain things in that are fireproofed but not things that aren't fireproofed. Finally, we're going to look at VoIP or voice over IP. Phones, which are now, this is sort of the new technology we're seeing a lot more in the market. This is what allows you to communicate using with a phone over an internet connection, using voice packets over an IP data network, which we will talk about as well. All right. So let's start by just discussing what a network device is in general. Basically, they allow communication between computers and nodes over media. The most basic type of network device that we've already discussed to an extent is what's called a network interface card, or a network adapter. This is what plugs into the computer and allows the computer to talk over the network. Okay? So what we're talking about are sort of larger network devices. And some of these are hubs, switches, access points. These are what the network interface card and the media plug into to allow multiple computers to communicate with one another. And so they allow connectivity between networks, not just between computers. So, for instance, routers and bridges connect networks together, whereas hubs and switches and access points, as you've discovered at home if you have a wireless network, connect computers together. Okay? So remember, these are what make up and remember these because whenever you see LAN, that's generally having to do with one of these devices, whereas WAN has to do generally with one of these. They also provide security and protection, such as a firewall and other devices like that we'll see in Network Plus that we're not going to cover here. So there's a lot of different devices, and they do a lot of different things. Let's talk about the first one, which we don't see much anymore, but we did 10 years ago, and there were quite a lot of them, hubs. This was the original connecting device for computers on the LAN. So remember, we looked at that star topology. You would have 4 computers that could all connect into this hub. And they connected into the hub. And now, automatically, I have a star network, right? There's a central device and all of them can connect to it. So wonderful, perfect, I'm done. Well, this is a really basic device. And the problem with it was that it only used one trunk circuit for multiple ports. What that means is, inside of here, all of these basically guys just all connect together. So when, I'm just going to write some letters on here, when A wants to communicate with B, it can't do so on a private line. If you are old enough, you might remember a party line for your phone, which meant that you'd pick up the phone and someone else in the neighborhood could possibly listen in. It was a party line. It was shared. In the same way, you're sharing all of this connectivity on the hub. So if A sends out a packet into the hub, even though it's only meant for B, it's going to go out to every computer. That's a distinction of a hub. When we get to switches, it does something different. So a hub regenerates the electrical signal from one port to every other port. So it's like if I walked into a room and I had a note for someone, and instead of handing the note to the specific person, let's say Bob, I announce to the entire room the note. And I say, this is for Bob, and then I communicated the message. So you can see how this is going to take a lot more traffic, network traffic, and it's not keeping things very private. So it causes, this is the real issue, it causes a lot of broadcast traffic because it broadcasts the data out to every other system that's connected to this hub. A switch, on the other hand, is also a central connecting device that allows all the computers to connect to it. But when it regenerates the signal from one computer, and I'm just going to, obviously this is a huge switch. Okay, so I'm just going to draw these. When it regenerates from one going to the other, it actually sends the data specifically to the computer it's meant for. So if I have all these computers, whereas a hub, if A wanted to communicate with H, a hub would contact every single one of these computers. A switch, on the other hand, uses the signal and takes it and only sends it to the person for whom it's dedicated. So a hub sends it out to everyone. It's like I'm going into a room and I yell it out. A switch takes that note and gives it specifically to the person to whom it's intended. It does this by identifying what's called the MAC, or physical address, of every computer. So each device on the network, and the switch has one too, has what's called a physical address. We're going to talk about these a little more in depth as well. But the physical address is basically its social security number. It is its name that it cannot change. And so what it does is it knows all the MAC addresses of every device on the network. And what it can do, therefore, is it creates a table and it says A equals this MAC address, B equals this MAC address, etc., etc. And so then when A says, I want to send a data to computer H, it knows by the MAC address which computer H is, and it can send the data specifically to that computer. So we're not broadcasting, we're using unicast now. We're sending data from one computer directly to the other, as long as they are all connected to this switch. Okay? So every port has an individual entity. This, therefore, increases data throughput and reduces excess broadcast traffic. I'm not having to send data to every single computer every time I want to send something. I'm just sending it to the person to whom it's intended. And that's going to increase throughput because it knows where it's going. It's not driving all around the city. It has a direct route. Now, a router is the next level up from a switch. It's used to connect two or more networks together to form an internet work, allowing data to leave and return to the local network. So, I have a switch, and it connects, let's say, 5 computers. And we'll call them 1, 2, 3, 4, 5. One of these computers wants to go to Google's website. Well, the switch is not connected to Google's website. What it needs to do is connect through a router. And the router is responsible then for sending that data out to Google. And then it comes back, the router sends it to the switch, and the switch can send it back to the computer. So again, the router allows us to get outside of our LAN. Switches are for inside of our LAN. Now, I might have several switches within the LAN, so I could have thousands of computers. But whenever they want to get outside of the network, to the WAN, we have to go through a router. So it routes data from one location to another by way of what's called an IP address. An IP address is a number given to every device on the network. Every device on the internet has an IP address. We're going to talk about those in much more depth. But it works at a higher level than MAC addresses. MAC addresses, as you could imagine, are like your social security number given out by the U.S. government, or a number given out by the military. Sometimes gives serial numbers to individuals. It does not change. It is you forever. Your IP address would be like the nickname we're going to call you. Or another way to think about it is your phone number would be a MAC address. Now, I don't know about you, but I don't remember a lot of phone numbers. I put them into my cell phone, and I just go to the name. So if I want to call Bob, I don't type in Bob's phone number. I just type in Bob. And then the computer does the rest for me. In the same way, the router knows how to communicate because it can deal with Bob. Switches can't do that. Switches need to know the phone number. And if I'm talking about a phone number across the world, that's going to get very difficult. So again, routers use IP addresses. Switches use MAC addresses, which are the hardwired ones. That might make a little more sense later on. The important thing to remember is that routers are dealing with the WAN and switches are dealing with the LAN. We don't really see hubs anymore because they're too much broadcast traffic. All right? And as I mentioned, they route signals for all the computers on the LAN out to the network. So even though I might have 1,000 computers, I only need one router. Larger organizations also will use advanced routers so they can connect to multiple networks outside of themselves, including the internet. This is something called a VPN concentrator or a VPN device. We'll talk about VPNs a little bit later, but that'll allow you to do other things than just connect out to the network. Wireless access point. This enables data communication over the air as long as the node, whether it's the computer, a printer, your smartphone, whatever, is equipped with a wireless networking adapter. So as long as one of these is connected to my computer, I can connect to the access point, the wireless access point. And don't forget, you can have, you can forget it because I haven't told you yet. You can have multiple access points that all connect through one switch. So if I have a very large building, I can have access points in different spots in that building. And then these each create a wireless network by which I can connect to my switch. And once I'm on the switch, I'm on the network. Okay? The access point, really what it does is it replaces bounded media. It replaces cords. So that's the important thing with an access point. It transmits the data using radio waves, and it uses either 2.4 gigahertz or 5 gigahertz frequencies. We're going to talk a lot more about wireless, or what's called the 802.11 standard, but just know that an access point is that device. Okay, so at home, you have something different. It is an access point. It is also a router. We're talking about a device that only is an access point. That's it. And it brings, as I mentioned, mobility to a new level because now you don't have to worry about being stuck by a cord. So a SOHO, or a small office, home office, access point and router. These have a bunch of things in them. They have a router built in. They have an access point built in. They have a firewall built in. They have something called a DHCP server that we're going to talk about in the next lesson built in. These things have tons of features. It's feature rich. Now, why is that good for a small office, home office? Well, I don't need a lot of features, and I don't need to have, they can be pre-configured. I don't have a lot of specialty things. In a business setting, though, I don't want one device that can do 10 things, because what if one of those 10 things goes bad? I've just lost the entire device. So that's why these are really used in small office, home office. And it's an important distinction to realize the SOHO access point as opposed to a plain old router. If they say SOHO router or SOHO access point, then that's something special. If they just say regular router, then you're not dealing with a wireless device. Sometimes they'll say a SOHO router, and they expect you to know that that means it's also an access point. Or a SOHO access point, and they expect you to realize that that's also a router. Okay? So sometimes when we're talking about these things, we're going to mention SOHO routers or SOHO access points. That is an important distinction to make. By the way, these can also be referred to as multifunction network devices, SOHO routers, and many people that you're going to hear in the field say, oh, my router. I have a router. Actually, you have a router, but it's really an access point with a whole bunch of other stuff on it. If you had a real routers for businesses can cost hundreds, if not thousands of dollars, depending on the needs. All right, a bridge. Similar in some ways to a switch in the way it works, but similar to a router in what it does. This is a device that can either connect two different LANs together or separate them into two sections. I'm going to explain why you'd want to do that in a minute. Let's say I have switches going back, and so I had a bunch of, let's say each of these is a switch. And every time, and I know these guys are never communicating with these guys. All this stuff creates network traffic. I mean, switches do a pretty good job, but still, there's a lot of network traffic going back and forth. And so what I might want to do is create something that's going to act as a buffer. So if a packet goes here that is meant for the computer on this side, the bridge will say, no, don't send it over. That keeps, if I erase all my terrible drawing, as these lines indicate, that keeps data. It keeps traffic from going over to the other side of the network. So in some ways, like a toll bridge in certain major metropolitan areas, they'll charge you a lot of money to go over so they can reduce traffic. This does the same thing. There are wired and there are wireless bridges. The wireless ones are used today to increase the size of networks. So you'll connect two LANs together using a wireless bridge, meaning that I have two networks, and I need to connect them over a long distance using a wireless sort of bridge. So they can connect these two networks, but generally speaking, and when I've seen them, it's generally to help reduce network traffic by blocking stuff that doesn't belong on this network over here. And when we get to Network Plus, we'll talk about specifically how it does that. But in A+, just know that it's reducing broadcast traffic. Network attached storage. This is a device that contains multiple hard drives and connects directly to the network. So it's like adding a removable hard drive or a USB hard drive, but to your network. So there's a RJ45 cable back here. Remember what those look like. Okay, and it connects that out to my switch so that every device can connect to this. Generally speaking, you're not going to see these in this form in a business setting, more in a home setting, these smaller network attached storage devices. There are larger network attached storage devices specifically for companies and larger enterprise. And the reason I want that is these do not have operating systems. Okay, so we can store and retrieve data from the devices mapped as network drives, which we'll talk about how to do, and we can explore them from the network, but from my operating system. But this doesn't have an operating system on it. It's plug and go. It's plug and play. I don't have to do anything special. So a network attached storage device, an NAS, specifically allows me to upgrade the storage on my network, but not on a specific computer. And because there's no operating system on this thing, there's less things that can go wrong with it. It also so as I mentioned, high-speed access to storage with no operating system. By the way, I just want to make a distinction between this and something called a SAN, a storage area network, which we'll talk about in Network Plus. So an NAS and a SAN, they're backwards from each other. But a SAN is a storage area network, which is like this, but an entire network of them. So instead of a local area network, it's a storage area network. It's a small network that only has storage devices. All right, a modem. This provides internet and WAN connectivity. So before we had routers and all this stuff, at least at home, and before we had broadband internet, we had no dial-up, right? And so the modem, which stands for modulate and demodulate, takes analog signals over the phone line from that like fax sound, if you remember dialing up, and it puts them into digital, so you can talk data, and then it converts it back again. So a modem modulates and demodulates network data and allows you to use the plain old telephone system or the public switched telephone network. Okay? Both basically the same thing. As I mentioned, changing digital signals of a computer to the analog signals used by typical LAN-based phone lines and back and forth, vice versa. Often, by the way, very slow device. I think it was limited to 53 kilobits per second was the fastest modem they were ever able to really come out with. I think actually it was 56 kilobits per second, but the problem was that the phone line could only support 53 kilobits per second. So compare that with the 15 megabits per second you're getting on your broadband connection. By the way, also used only if there's no other internet option available nowadays, or if you're in, and believe it or not, there's a lot of people who still are dialing up, as odd as that is for certain people in metropolitan areas. A lot of rural areas, you still have dial-up networking. So also might be used in server rooms as points of remote administration, meaning I'm going to dial into my server room in order to access things and to make changes. Nowadays, however, this is probably done over the network using some security. All right, an internet appliance refers really to any device that enables easy connectivity to the internet but doesn't really do much else. Here I have, if you recall, I don't remember if you guys remember this, but I do, a web TV, which was a device that was basically a computer, but it connected to your TV, allowed you to get email and browse the internet to an extent, but it was not a fully functioning operating system computer. It had an operating system, but the operating system's goal was simply to allow you as a user on your television to access the internet. So web TV is a good example. Some people refer to tablets as an internet appliance, although I disagree, because I think a tablet or a smartphone is now a computer. And I think these are computers too, so it's sort of it's sort of a legacy term, because nowadays we don't really have devices that only get to the internet. This also might be sort of like a thin client, because it is only connecting to the internet. It's not really doing anything else. But either way, if you see internet appliance pop up in the exam, now you know what it is. Finally, I want to talk about Firewall. This is a hardware or a software appliance, so it can exist either in a physical hardware, like your Soho router, or it can be a piece of software, for instance, on the computer, that protects from unwanted intrusion. For small offices and home offices, the Firewall is built into that Soho router. So you have a Soho router that generally is going to have this Firewall built into it. In larger organizations, you literally have a device called a firewall that plugs up. So what it does, like a fire, it allows some stuff in and some stuff it does not allow in. So if you use some arrows there. So some of it lets through, some things it doesn't let through, and the reason it knows what to let through and what not to let through is based on what are called rules. And you can create inbound and outbound rules. So out would be this way, in would be this way. Okay. It can also block basic networking attacks. Most, if they're really good, they're going to be able to get past it anyway. But the idea is, why would a burglar rob your house if you have a lock on it and your neighbor doesn't? So you want to give yourself as many options not to get attacked than to get attacked. So it can block basic networking attacks and might deter someone from trying to break into your network. If you have a Soho firewall and a firewall on your system, you're doing double duty. You have double the amount of protection. And last but not least, I want to discuss these voice over IP phones. Voice over Internet Protocol, it's basically a collection of technologies and protocols that allow communication over an IP-based network. We're going to talk about IP addressing later. But the idea is we're not using POTS or PSTN anymore. That's the plain old telephone system or the public switch telephone network. We have this great internet now, and the idea is, well, let's use that to communicate voice. Because voice is different from data, because it has different requirements. For instance, data, if I'm reading a document with data in it, and let's say an E gets dropped on that, right? I can probably make it out, or I can ask them to resend it. But if I'm on a phone call, I don't want to have to ask the person to constantly repeat what they're saying. So this is really a replacement for POTS and PSTN, and it took a while to get to because new technologies had to be created. These VoIP phones, by the way, connect directly to the Ethernet. You can see the cord sort of popping out here. This is not an RJ11. Okay, this is an RJ45. You can see it's made by Cisco Systems, which is the major networking company. All words spoken are converted into packets, data packets. Those packets are then routed through the internet to the other end. Anything about routing and getting past our internal network to an external network, we're dealing with all sort of new technologies. And if it's not implemented properly with something called QoS that you're going to see again and again in direct reference to VoIP, which stands for quality of service, which is also a series of technologies that guarantee, for instance, that when I talk, you can hear me. Otherwise, we're going to have sound quality and latency issues, meaning I'm going to say hi, and you're not going to hear it for 5 minutes. Sound quality as well. I can't have dropped packets or dropped sounds. It has to be really nice. Otherwise, the technology is not going to be good enough to replace POTS and PSTN. Fortunately, there has been enough technology sort of advancement that we can. All right. So let's just go over what we've talked about. We talked about network devices, which are really allowing us to communicate not only between computers, but also between networks, and they can also provide security. All right, then we looked at hubs, which broadcast data to everyone, okay? Not just to the one person, right? They broadcast to everyone, and so they have a lot of network traffic. A switch, which sends data only to the computer for which it's intended, or the node. And it does this using physical or MAC addresses, which we will talk about in more depth, if you're a little confused by that, okay? Routers, on the other hand, allow communication outside of the network. Or into the internet, or WAN. We also have a wireless access point, which allows unbounded or Wi-Fi connections. A Soho router, which is not only an access point, it's also a router. It also is a firewall. It is also, to some extent, a switch. It is also, to some extent, other devices that we haven't talked about, like a DHCP server and an NAT server, network address translation. We will discuss these in a bit later on. A bridge, which either connects or divides LANs. Network attached storage, which is high speed high amount of storage for a network directly. A modem, which allows WAN access, or LAN access, really, but it allows WAN access via the PSTN, Public Switch Telephone Network, or POTS, plain old telephone system. The Internet Appliance, which is any sort of appliance providing access to the internet, but not much else, almost like a thin client. A firewall, which is really protecting, but allows certain things in. And VoIP, or voice over IP phones, I'll write that out, voice over IP, which allows voice communication over data packets. All right. So we've discussed all the different network devices. Now let's keep talking about media and how we're going to connect these devices to one another.